Assalamu alaikum everyone. So lecture number 12, and we will be talking about protocols and the TCP IP protocol suite. So first of all, we will discuss why we need protocols and how we require a protocol stack, right? If we talk about the requirement of protocol in the context of our course title, that is wireless and mobile computing. So let me share that you know that most of the services, they are now becoming available via GSM or maybe some other technology that is actually wireless technology, maybe WiMAX or Wi-Fi. So all, if you look into more details, all those technologies, they actually are relying on a backbone infrastructure, and that backbone infrastructure is actually based on or following some sort of protocols, right? So if we talk about the services, the applications that are available nowadays over the wireless and mobile computation or infrastructure or networks, they actually are IP based, right? So in order to develop those different apps, different services, in order to use those services in an effective and efficient way over the existing infrastructure, we need to grab some of the protocols that are necessary or that are very important in order to use those services. So that's why we will be talking about this TCP IP stack, and before that we will talk about why we need protocols and how the evolution actually came after the requirement, and it evolved in steps, right? So first, everyone knows that the requirement was felt by DARPANET, ARPANET. So then they start developing some basic protocol, and with the passage of time, that protocol development actually results in a very matured and standardized protocol stack that is being used heavily over the internet, right? So if some equipment or some service or some app is not supporting TCP IP stack, then it means that we cannot communicate. They have to build their own infrastructure in order to have equipment, services and apps will be communicating with each other. So here are some of the bullets that we will be going through. First of all, we will establish that why we need a protocol. Then as we know that TCP IP is a stack that includes a bundle of protocols, and in that stack each protocol actually is working or functioning at a certain layer. So why we need a layered approach in order to develop the protocol or in order to have the protocol. Then we will be talking about key features of the protocol, and we'll be focusing on TCP IP, that protocol stack. And we will start by taking into account a simple protocol architecture and addressing, which is one of the important component or element of the protocol. We will be discussing the addressing and different addressing schemes, and then we will compare the standardized OSI model and the TCP IP stack, and finally we will talk about the general networking terminologies. So let's start. First, we will be discussing why we need a protocol, right? So as I'm delivering the lecture, right, and you people are listening, so there is some rules and regulation that I have been briefed before I started delivering lecture over here, right? That I will be presenting lectures, and then I will be following certain set of rules, right? And if, for example, we take another example that we have 3 people, and 2 of the people, they have different language, and 1 people that is sitting in between, he or she know both the languages that is spoken by the 2 end users or 2 users that actually want to communicate, right? So there should be some methodology, some sort of protocol that has to be followed, right? So the person in between, he know both the languages that is spoken by the end parties, person A and person B, and the intermediate person will be communicating. So he will be listening to one person, then translating it, and then communicating this the message to the other person, right? So this is a very simple example of the requirement of a protocol, right? So first they decide that how they will be communicating, and then the intermediary person should know that I have to listen from one side and then communicate to the other side, and then the other side will respond, or maybe there is some other mechanism so that the end parties and the 2 people, they can communicate with each other. So this is the best example, right? So we can also have another example whenever we talk to a child, right? So he can speak very few words or very few things, right? So you need to communicate some message to the child, right? So that is another example that we can take, that we need to define a protocol, we need to define a mechanism, some way in order to communicate our message, or in the similar way, whenever child want to communicate something, he or she also follow some mechanism in order to communicate. For example, if we have a very little child that cannot move even, so he will start weeping, right? If he's hungry, so this is also a sort of communication, message communication, that he's hungry, or maybe there's some other problem or some other situation or scenario. So this is some of the examples which we can take from our daily life, right? So let's come to the point that why we need protocol architecture. So whenever we talk about the communication, right? So before we start communication, we need a path, right? So as I have mentioned, the example of 3 people, and the intermediary person, he know the languages that both the end parties they can speak, but if they are sitting at a very, very long distance, so there will be a problem. So first, what they need to do, they need to establish a path, or they need to sit so close so that they can listen to each other, right? So first you need to activate the communication path, right, from source to destination and from destination to source, because if it is a two-way communication, then let me talk about the 3-person communication example again. So there must be a protocol there must be certain rules that if one person is talking, the others two, the intermediary person and the third person, they will be keep silent, they will remain silent, so that the message has to be conveyed properly, right? And if one person is talking, he has to make sure that the intermediary person is receiving the message in a proper and effective way, right? So that's the same requirement whenever we talk about the communication between source and destination. Then the source, it's the responsibility of the source, or maybe in some cases the responsibility of the intermediary person. In our example, that the data is being received properly, right? And whenever we talk about the computer communication, what we need to do, we need to transfer files, we need to send messages, we need to share images, and so on and so forth, right? So there are certain applications that are actually doing so at the top, right? So we need to ensure that if we have to transfer a file, then in that case we need to ensure that at the destination the file application that is going to receive the file is properly initiated and activated or launched, right? And then again a format, right? Or maybe translation function is required, right? If the systems are different. For example, if I'm using an app on a Windows, right, that is transferring a file, on the other side I'm using an app on the Mac, right? So maybe we need some sort of translation or media transcoding if the two systems are not compatible, right? So this is also has to be compatible. So that's why I have taken the example of 3 people, and 2 people, they spoke different languages, and the intermediate person, he or she know both of the languages, and he can translate and communicate message to the other. So we need transcoding. So here we have a very simple task, that is the data transfer of data from source to destination. And you can see that here we have to take into account, or we have to be consider 4 different tasks, right? One, source must be activated, right? Or then there should be a communication path from source to destination, and then this source must ensure that the destination is prepared to receive data, right? And then if we are using some applications, for example, we want to transfer file, so we need to ensure that that the endpoints, they are actually compatible, and the same sort of application is launched at the destination, so that they can receive, there can be a communication in a proper way, right? And finally, if the 2 systems, they are different, right? They are having different architecture or different operating system, and maybe different data representation, so we need a translation. So we need 4 different steps. So those different steps, they can be divided into 4 different tasks, and we can have 4 different layers in order to perform one task at each layer. So here comes, if I bundled or grouped those different tasks or layers into one stack, so I need to define a protocol, right? So, and that actually will define the architecture of the protocol. So here we have functions of protocol architecture. So our objective or our target is to communicate, right? In case of our familiar example of 3-person, in which both the end persons, they have different languages, and the intermediary person, he or she can speak and communicate by using both languages, right? So the task is communication between two end persons, end people, right? And we can break that communication task into different logical steps or submodules, right? And then if we have different layers for different tasks, right? And then we can arrange those tasks one above the other, and in this way we will be forming a vertical stack, right? So each layer actually is performing a task, right? So here, as if we talk about the computer communication, right? So we need to transfer data from one computer to another computer. So there are a lot of different steps and tasks that are involved, and if I divide those tasks into steps and I arrange those steps in a stack, right? So or in a vertical way, then I will be having a layered stack, right? So at each layer there will be a different task in order to ensure the transmission of data, or in order to have the communication from one computer to another computer, right? So each layer in the stack performs a subset of functions, right? So task, you can say it's a set of functions, and then of course if we talk about the layering approach, there can be a possibility that the next lower layer relies on the next layer, right? So there can be another point that is very important, that the changes in one layer should not require changes in the other layer, right? So if we have a stack, so this is not necessary that there should be a change at each layer, right? So changes in one layer should not require changes in other layers. So there is no dependence, it means. So here we have the some of the key features of a protocol. So as I mentioned, that in case of 3 people communication example, we need to fix certain set of rules that if one body is talking, the others too has to be silent, right? After one person finishes his communication, he can say something that, okay, now I've finished and you can start. So the other person can start, or there are some rules, right, in order to have effective and efficient communication, right? So similarly, if we define or organize those rules in a certain way, we can call them a protocol, right? So here comes the simple example of a communication, data communication between 2 endpoints. So first of all, we need to define the syntax, right? So how we are going to represent the data, right? So that is about the syntax, right? Then what semantics that data is actually having, what sort of semantics, that is all about the control information for controlling the flow information, right? And for, if in case of error, if somebody doesn't understand and he want to repeat this conversation again, so this is all about the error detection and then error correction, that is error handling. And then of course the timing, scheduling, sequencing, this is also important, that when the 2 endpoints, 2 computers, they want to communicate, So at what time they should start? They should first look at the media that is shared, right? If this it's dedicated media, right? So then in that case they have to follow some other rules, right? So they have to look the destination, that either it is free or it is ready for receiving the data. So and the capability of the destination. For example, if I'm sending data at a speed of 1 megabit per second, but the destination on the other side, it don't have the capability to receive 1 megabit per second, right? So there will be a problem. So speed matching, scheduling, and sequencing of data, that is all about timing. That is also one of the key feature of a protocol. So let's talk about a simple protocol, right? So whenever we talk about a protocol, there are different agents that are involved in order to have communication by using that protocol. So we have app at the top, application, and then that application is actually running on a computer, right? And that computer is connected to a network, right? So three agents are involved: application, computer, and network, right? So, and one of the example we can take is email, right? So you know that whenever we talk about the email, right, so we have the application, or maybe a browser, or maybe email specific application, for example Thunderbird, or maybe some other application that is actually used in order to send and receive email, right? So on the source side, the email application has to be executed, right? And then you know that we have servers and then intermediary devices that are being involved over the network, right? So the email will be sent, and it is received by the server, and at the server we will be sending that email to the recipient, and that is the destination, right? So this is a very simple scenario where we can define a protocol, right? So we have application, we have the computer where the email application is launched, or you can also take the example of a file transfer protocol, or FTP, that is being used in order to send and receive data between different endpoints, right? So, and then of course we need a network infrastructure in order to have the communication. So here we have the communication layers, right? So we will be talking about the communication layers, right, in order to achieve communication between endpoints, right? So we have actually three independent layers when we talk about the communication task, right? Network access layer, of course you need to access the network, and then the transport layer, and then the application layer, right? So at network access layer, it's about the exchange of data, and then transport layer has to ensure the reliable data delivery, and on the application side we have to make sure that the both end parties, they are actually supporting the same logic, or they have support for the same application, right? And then we have the network access layer, right? So you can see that we have communication layer, and here we have network access layer, right? So it includes the exchange of data between the end users, right, and the intermediary in devices that are actually available within the network, right? So of course if we want to connect two computers via some media, right, so we need some intermediary devices in order to connect those two endpoints, right? So of course for that we need addressing, destination address, and we also have to take care of the services and priorities, which station has what sort of priority, then access and routing, right? So these are actually the responsibility of the network access layer. Then transport layer. So of course here we have to ensure the reliability and redundancy, right, in the context of the data. So irrespective of the application which is at the top, here we are actually concerned about the content, about the data, right? So the data delivery has to be ensured, right, when we talk about the transport layer. And then application layer. Of course, if I'm using an FTP application at one computer, right, and I'm using an FTP application on the destination computer, right, so the logic should be compatible, right? Or you can also say that at least if the applications are different, they should be following the same protocol in order to send and receive data. For example, we can take the example of FTP apps. There are a lot of different FTP apps where by using those different apps we can transfer data, but the condition is that they should be following the same protocol or same set of rules. So here we have an illusion of protocol architecture and network. So you can see that we have three layers: application, transport, and network. So if we talk about the application, so it cannot do anything in the standalone mode, right? So it need to transmit data to the transport, and then transport layer will be sending data to the network, and then at network layer we can see that we have the core network devices that actually are communicating or that actually is connecting those three different computers, right? But how we can differentiate that this application is for example FTP, or this is the transport rule that are being followed in order to have the communication, right? And then finally how they will be accessing different computers by having the core communication infrastructure that is actually connecting those three different endpoints, right? So you can see that at the application layer we have the ports, right? And then again at the transport layer we are following certain protocols and then certain mechanism. For example, we can have TCP, UDP, and some other transport mechanisms. And at the network access we should be having a addressing scheme so that each node should have a unique address. For example, if this computer A has to transmit data to computer C, then there should be some mechanism or some addressing that this data has been communicated to computer C. So this is you can see the proper application of the architecture, protocol architecture, and how they will be having their own headers and control information when we talk about the communication. So here we have the practical example, right? So for example, you can see that now we have data, and that is at the application layer, right? So that data has to be communicated by using some port, and that will go to the transport, right? And then you can see that at the transport layer we have some other headers that are being included, right? And that data has to be communicated to the network layer, and network layer will add its own header, and then that complete data will be transmitted over to the network by using the core infrastructure. And then of course at the network level we have some sort of addressing and some destination pointers, so that data will go here, right? And then you can see that those headers, they are being considered in the reverse order, right? So transport layer will have its own data, and then finally we know that this application layer will be reading out its own header, and our communication will be going on in this way. So as mentioned that we need to follow certain addressing scheme, right? So if we talk about the computer communications, right? So each computer should have a unique network address, right? So if we go further up till the application layer, so each application layer should also have the address, right? So those sort of address we have port addressing, and for network level we have the MAC addresses, or maybe in between we have some other sort of address mechanism. So we talk about the layers, and then the data at different layers. Some of the data is about the control information, and the rest of the data is actually taken as the original data, right? So the combination of data and the control information is called a protocol data unit. So that data is considered as the original data for the next layer, right? And control information is contained in the PDU header, right? So there are some different informations that are included in the control information: source address, source port, destination port, sequence number, and error detection code. So there should be an error detection mechanism in order to. Then if we talk about the network access protocol, so when we receive the segment from the transport layer, because at the transport layer we have segmented data, the network access protocol must request transmission over the network, right? So network access protocol creates a network access PDU, right? That includes the data plus control information, and the headers they actually include source computer address, destination computer address, and facilities request. So here we have the TCP IP architecture. Actually we can say TCP IP is a stack of protocols. We have different layers, and at each layer we have different protocol. So it's a bunch of protocols, or you can say that the stack of protocols that are bundled together in order to achieve the communication over the network, right? So here we have the layers, their names and the functionalities, and the corresponding stack of protocols. So if we talk about the application layer, right, so it provides access to the TCP IP environment. Of course, if we have a network and over that network we have TCP IP support, so the applications should be communicating with each other by using the TCP IP stack, right? And the users and the applications, they are actually using TCP IP in order to send and receive information, right? So at the application layer we have a bunch of protocols that includes the SMTP, simple mail transfer protocol, FTP, file transfer protocol, and then SSH, that is for command line communication, or secure socket, and HTTP, hypertext transfer protocol. So these all are application layer protocols. Then we have the transport layer that is at the next to the application layer, right? So the functionality includes the transfer of data between endpoints, right? So the transport layer take care of the data transmission between endpoints. So here we have the communication between applications at the endpoints, or here we have to ensure the transfer of data between endpoints. So there are a lot of functionalities at the transport layer. Of course, as it is concerned about the data transmission, so we must have some sort of error control, flow control, congestion control, and we have to ensure the reliable delivery of data. And the protocols that it support, it's TCP, transmission control protocol, and UDP, user datagram protocol, right? So one is connection oriented and the other one is connectionless protocol, right? So we have two protocols, although there are some extensions to those different protocols in order to overcome some of the shortcomings that are being provided by TCP and UDP. So we will not go into more details regarding those two different protocols that are being supported by transport layer. And then we have the internet layer, right? So this actually is shielding the higher layers from the lower layers, right? So it is providing shield between the upper layer and the lower layer, right? And the tasks that are being performed at internet layer is routing, right? And it has to ensure the quality of service, right? So there are certain protocols that are being supported, IVP4, right? That is at 32-bit address, and IVP6, that is the latest one, that is 128-bit addressing scheme. And then we have a lot of other different protocols, ICMP, OSPF, Open Shortest Path First, RSVP, and ARP, Address Resolution Protocol. And then after the internet, we have the network access, right? So it's a sort of layer which is providing interfacing between different hardware devices by adopting certain standards mechanism. For example, Ethernet, Wi-Fi, ATM, and frame relay, right? So it's providing the actual network access. If we have a network that is actually Ethernet based, right? So this network access layer will be providing the interfacing between different devices over that network. And finally, of course, we have to transmit the data over some media, and that media can be a twisted pair, optical fiber. We can also have satellite communication, or we can also have terrestrial microwave, right? So it includes the transmission of bit stream, and we have encoding, decoding techniques, and we also will be caring about data rate and the bandwidth that is available, for example, for the twisted pair, for the optical fiber, and so on and so forth, right? So this is about the physical media, and of course we need if one network support Ethernet and the other network is supporting some other technology, right? So there can be possibility that if Ethernet is using twisted pair, and if we have some other technology, so for example Wi-Fi, so it is using the free space, right? So we have to arrange proper termination of those different type of media. So here we will be talking about those different layers individually, right? So physical layer, it covers the physical interface between computer and the network. So as I mentioned, so we will be talking about actually whenever we talk about the physical layer, we have to represent data in the form of signal, so that it can traverse from one point to another point by using some media, for example fiber optics. So in that case we will be using light in order to transmit data from one point to another point, and there should be a proper termination, right? So we should be having the proper equipment at the end points, so that we can first, if we are talking about the source, so the electrical signals has to be converted into the light signal in a proper way, and then on the receiving side the light signal has to be converted into the electrical pulses, so that we can receive that data in the form of the bits and pieces, right? And then we also will be talking about or caring about the data rates, right? So as I mentioned that if we have a backbone on a fiber, and our network is based on the Ethernet technology, right? So we will be taking care about the data rate, because fiber is high speed media, and Ethernet, it has its own limitations, right? So we will be also concerned about the data rates. And then network access layer, right? So it is actually about the exchange of data between an end system and the network, right? So of course our systems, our endpoints, they are connected to each other via some network infrastructure. So those sort of network infrastructures, they are having different devices, different media, and then we have to consider the exchange of data between those network devices that are the core devices within the network and the end systems, right? So we will be taking care about the issues, the addressing scheme, right? And then the services, their priorities. For example, if we talk about some services, they have very high priority, they should be allocated good resources, right? So, and then we will be also talking about the routing, right, over that network access layer. And then internet layer, right? So it implements procedures needed to allow data to travel across multiple interconnected networks, right? So as we can define internet as network of networks, right? So we need a proper protocol in order to have communication between network of networks, right? So for that we need a protocol, and we are actually using IP, Internet Protocol, to provide routing functionality, so that we can have data transmission and reception between network of networks. And then we have communication from host to host. It's concerned about reliable delivery of data, so we have to ensure that the data is received reliably, right? So at the transmission layer or transport layer, we will be concerned about the reliability and redundancy. And the protocols that are being used, they are actually TCP and UDP. One is the connection oriented, and the other one is connectionless protocol. So here we have the operation of a TCP IP stack, right? So here we have host A and host B, right? So app Y, application X, right? So you can see each application has its own dedicated port, right? So application will be X will be recognized over the host B via a port. Then we have TCP IP, right? So global network address. You can we have different IP schemes, right? And we have different classes of IPs, class A, class B, class C, and this addressing scheme is used globally in order to have the communication over the network of networks, that is internet. And for local area networks, we have some of the classes that are reserved in order to have communication over the LAN, But remember that those IP addresses, they are not routable. If we will be using those addresses and we wish that those addresses will be routed via router, so this is not the case, right? So we have to do something else in order to have routing, right? Then we have network access protocol 1, right? And here we have the physical. So this is the media, right? So you can see that we have here we have intermediary devices over the network infrastructure that can have routers, switches, and some other devices, right? So here is the functionality of TCP IP, right? So addressing requirements, each host should be having its own unique address, and then each process within a host must have an address. So here we have mentioned the TCP IP addressing, right? So you can see application layer. So we have addressing at application layer, that is application specific addressing, right? For example, port addressing, and then we have transport layer, right? So again, TCP have a certain port. Then network layer, we have logical addressing, that is about IP addressing at the network layer, and then here we have the physical address at the data link layer, that is about the MAC address, medium access, right? So here we have, for example, at the application layer we have user data, that is actually sending data from one point from source to destination. So this user data, or application data, will be received by the transport layer, and then transport layer will be adding its own header, right? So this is the control information, and that chunk of data will be sent to the IP layer, and that IP layer will be taking this data that includes the data from the application layer plus control information at TCP layer at the original data, right? So you can see that that is taken as the data, and then IP layer will be adding its own header, control information, right? And then at the network layer we will be doing the same, right? And network header will be added, and then we will be transmitting that data over to the physical link, right? So here we will be talking about the transmission control protocol, right? So it's here comes the header, right? So you can see the header, source port, destination port, sequence number, acknowledgement, right? So we have different flags, and this is for error, checksum, urgent pointer, right? So we have, and here comes the UDP, right? So that is also a transport layer protocol, right? And here is the header of UDP, and IVP6 version 6. So we have IVP4, but due to the unavailability of number of addresses, we need to invent IVP6, and IVP4 it has 32 bits, but for having large number of addresses we need to enhance the number of bits for source and destination addressing. So here we have 128 bits for the address, right? So here we have the IVP6 header, destination address, source address, right? So most of the bits are reserved for source and destination addresses. So here comes TCP IP protocol, right? So you can see that we have MIME at the top, multi-purpose internet mail extension, right? And then we have BGP, border gateway protocol, FTP, and different other protocols. And this is the transport, right? TCP and UDP, and here we have the IP layer, right? So, and over that we also have the some other protocols. So this is you can say protocol stack that we all also have gone through, right? So I will be skipping that, right? So let's talk about the OSI standard, right? So framework for standardization, right? And each layer has its own functionality, so we will be focusing on three key elements: protocol specification, service definition, and addressing, right? So here, request, indication, response, and confirm, right? So I will be skipping this, right? So here we have, right? So before the support or for multimedia, we need to know some of the multimedia terms, media, right? So that actually includes the information, right? Or the data types, different data types that includes the text, still images, audio, and video or moving images. Multimedia, so of course human-computer interaction involving text. So for example, we have a video conference, right? That is one of the example of multimedia application. So where we will be having video chat, right? And in that video session, we can also have the provision that we will be sending and receiving files, and then we can also have messaging involved, right? So there are some techniques in order to have reliable communication, that is the streaming, right? So here we have defined audio, images, video services, and text, right? So that's what we all know. So multimedia apps, right? So we have different applications that right? So here comes the elastic and inelastic traffic, right? So the one have the flexibility to adjust accordingly, right? For example, whenever we talk about the quality of service sensitive services, that includes voice and video, right? So for example, in case of voice, we cannot accommodate the delay or jitter, right? So but in case of video, we can accommodate the delay by defining the buffer, so that whenever we play a video, we can define a buffer of appropriate size, so that most of the frames or the frames at the before the start of the video, they has to be stored in the buffer, right? So in that way we can overcome the delay, right? And then we can also have some sort of problems with throughput change, right? Whenever if we have a shared medium, then there can be a case when the throughput changes, right? So when we have, if we have 10 users on a certain link and suddenly they are 15 or 20, then the throughput for each user will be changed, and then we can also have, so the ongoing services, if they have the capability or the to adjust accordingly, then we will put those services into the category of elastic traffic, right? And then we have inelastic traffic, and of course that is the traffic that do not adapt to delay and throughput, right? So that is the traffic such as voice and video. We can also make this traffic to adapt, but to some extent, right? See, in order to have the protocol architecture, protocol stack, and the communication, if we want to mix different switching techniques and different standards and different protocols, so we need to know some sort of internetworking terms, right? So these are very important when we want to define different technologies, standards, and we want to talk about the protocol stacks. So first of all, end system, right? So that is actually the end device, right? That is actually that want to communicate over a network by using some application or by using some services. Then we have intermediary device. So in the core network, we have endpoints, and then we have the intermediary devices that are actually can be nodes or different some devices that actually are used in order to connect the endpoints. Then we have a bridge. When we talk about a bridge, normally we have LANs, MANs, and WANs, right? So if we have high speed infrastructure regarding LAN, MAN, and WAN, so we can use that infrastructure in order to have a backbone, and can develop the wireless infrastructure over that high speed backbone, right? Or we can connect those different different networks in order to have a bigger infrastructure, or we can take the example of internet, that is actually network of networks, right? So in order to connect different two different LANs, we can have different devices, and bridge is one of the devices that can connect two LANs, right? Then we have a router. So that is a very important device when we talk about the network communication or any form of communication, right? So it's actually used to connect two networks that may or may not be similar, right? So one of the difference between bridge and router is that whenever we want to connect two LANs, right, and in order to use the bridge, so this is one of the condition that they should be using, they must be using the same technology, right? So the LANs should be similar. So in case of router, this is not important that the two LANs that has to be connected, they should be similar, or because we have support for different technologies in case of a router, right? So here we have the functionality of our router, because this is very important component of a network. So it provides link between networks, and the functionality includes routing and data delivery, right, and between different networks, right? So it provides a link between networks, and then we can also have routing, right? So these two functions are performed without requiring any modification, right? So we don't need to modify the two networks in order to have routing and connection between those two different networks, right? So then we can have different addressing schemes when we talk about the routers, and there should be a mechanism in order to have the dialogue for the packet size. Then we can have support for different interfaces, and of course as a result we have reliable data communication. So that's all, and today we talked about the protocol stack and why we need to define the protocol in order to have communication, and what are the advantages of adopting the layered approach when we talk about the protocol design. And then we have taken a very simple example of a simple protocol that actually is consisted of 3 layers, and then we talked about that how each layer is adding its own header, and at each layer we have different tasks, and then there is some control information that has to be added in order to perform that task in an effective and efficient way. Then of course we have to define certain addressing schemes for different levels. For example, if we have a host station where there are different applications, and that application has to be transmit data from one source, from one point to another point by using the infrastructure of the core network. So there should be addressing scheme for application level, then at the transport level. So we have different addressing schemes at different layers, right, accordingly. And then we have compared the TCP IP stack with the standard OSI stack. And finally, we have learned about some of the key elements of the network and their functionality. So that's all. अपना ख्याल रखिएगा. मेरी तरफ से अल्लाह हाफ़िज़. अस्सलाम वालेकुम.